Hello my dear champions, good morning to all of you. I hope you have slept in the night. Yes, if not, please bacha try to take some rest. I am here with revision on the 30-minute session. So what I'm going to do today is basically talk about some important formulas, some important results, the question that can be actually expected in this examination. Okay, so all these list of questions, and not only questions, I'm going to give you a hint to solve all the problems over here as well. Okay, so first of all, I hope you have rested well. And if some of you are night owls who just stay up all the night, but still I'm telling you, even if you have stayed till late night, try to get some rest before examination. Again, one important update for all of you, and that update is regarding that I'm coming live beta. I'm coming live at 5 a.m. Okay, I'm coming live at 5 a.m. and the sole agenda of this live is to support you mentally and to cater to all of that, hesitations, all those doubts that you have, all those confusions that you have, whatever clarity that you need. For that, I'm coming to support you all at 5 a.m. Otherwise, I've done already everything that you need to do to prepare for mathematics. And trust me, your preparation, if you have followed me, is done up to 100%. We have done everything that you need to do to prepare well for your boards. Okay, so first of all, give yourself a big, like a clap, thumbs up that you have done a great deal of hard work. Now you're here to look at revision under 30 minutes. I know your time is important. Let's get back to the session itself. Why to waste your time? So starting with, what do we have? Of course, it is 30-minute revision. Let's look at this. So in the session, I'll talk about your hints of all the questions, hints in questions, in the important questions, and also give you summary of everything. Summary. In this, I'm going to use NCERT. I saw many of you talking about this in the yesterday's live that, sir, I have not even started, I have not even looked at the NCERT. Then it is a problem. Okay, you have to prioritize better NCERT, right? So look at the summary of the first chapter if you have. Again, all the definitions are given over here, so you can go through them one by one. Okay, for empty relation, what is it? There's none of the relation element in the relation will be part of x cross x, universal relation, reflexive relation, symmetric. So these are the important ones: reflexive, symmetric, and transitive. A question will come on this for sure, so I hope you practice on that. How to check for equivalence? You start with f of x1 equals to f of x2, and you end up with x1 equals to x2, means the given function becomes what is it called, 1-1 function. And for onto function, what happens? You find the range, and range is equal to codomain. How do you find range? Whatever function is given to you, beta, just write the function as subject to y. Whatever is the function, let's say x square plus 1, and then from here make x subject as root of y minus 1, whatever it is. Okay, and then check the, what is the range over here? More than 1. So range becomes y equal to more than 1. Just giving you an example over here, okay, nothing else. So again, if you go about, this is very, very important. MCQs will come on this beta. MCQ will come on this. What is that? Your domain and range of inverse trigonometric function. So please do not take them lightly. And basically, so this session is over here. You might not get PDF on time, whatever is going on, but you have all these summaries available in your NCERT. So please go through them right now. Very, very important. Okay, very, very important. At least for chapters that you are confused in or that you make mistakes in the formulas, please go through them. Everything listed over here. Okay. Similarly, this is for determinants. Please check. And if I have to show you the most important one, this is for continuity. You can check here. This is the algebra of continuity. Over here also the question comes. MCQ can come from this as well, beta. Okay, and this is some important derivative. Again, for normal functions, we know the derivative very well, sine, cos, tan, all those. Some ITF functions derivative are listed over here. So derivatives are relatively easier. Again, this is important question. A 3-mark question will come from here, sir. Logarithmic differentiation, where the form are over beta. The form is f power g when two functions are given as exponents or powers. Either you have two functions in product or two functions in quotient. Okay, f by g or f by q, whatever is given. In those situations, we use logarithms. Okay, the properties of log, if you remember, let me just write that for all of you. If you have log of a power b, the formula is b log a. Okay, let me just write all the formulas of log once, okay, which is important. When you have log of a power b, this is nothing but b log a. When you have log of a into b, it becomes log of a plus log of b. When you have log of a by b, this becomes log of a minus log of b. Anything else we have? Yes, we have one more property. Whenever you have log of, let's say, a power m and base is log of b power n, this becomes log of a with the base b, this m comes in front numerator, n goes in denominator. So m by n comes beta, m by n comes, okay. So these are the basics formula which is there for your logarithms. You got to use it, okay. Moving on. This is for AOD, your first derivative test. To understand this, when derivative is positive, it is going to be increasing function. Derivative is negative, is going to be a decreasing function. For local maxima minima, we don't use this. We directly use the second derivative test, and for that, we have the steps involved over here. You can check this out. When f double dash of c is more than 0, it is local minima. Please check beta. F double dash of c, the c being the critical point, more than 0, this is local minima, okay. And when f double dash of c is less than 0, this represents local maxima, right? How do you find c? How do you find critical point? Derivative, you're gonna find f dash of x and put it equal to 0. Whatever values of x which will make the function 0 are called as critical points, okay. Again, I've taught you all these things, but still reminding you one more time, okay. Now, summary of integration. When you have constant involved, you take constant outside the integration. You have two sum of functions, you can integrate them individually, then add it. All the properties are here. I know you all know it, but still please go through each and every one of them from NCERT summary. Make a, just it'll take half an hour basically or 20 minutes. Please go through it, okay. For partial fractions, we have two critical points. So these are the two basic forms. So these ones, and there's one more, this one, okay. So either of these forms can come, please use it. Other forms are less likely to come, but still it's good to know them. I know you already know them very well, okay. So for substitutions, these are some important results that you get. Integration of tan, cos, we keep using this one a lot. We keep using this one a lot. Even this we keep using. For this we also have one more formula, minus of log cos x plus c, okay. So use these formulas, okay. This we have log of tan x by 2, okay. For this one we have log of tan x by 2. That also is important. Some particular functions integration are listed over here. Please remember this formula. Directly question can be there in MCQs, that they can ask you what is the answer for this. One of the options will be here. You have to pick the right option and get 1 marks, okay. So these are some important formulas, again here listed over here. So all the formulas that is there are very, very crucial beta. Please go ahead, learn once from the NCERT summary. I've listed only for first 7 chapters in the time that I've had, but you all have NCERT book, right? Please go at the last page, you'll find the summary. If you don't have online, you can go to the NCERT website and textbook you can search. You'll get all of them for free PDF. Okay. Now let's get back to hints for important 5-marker questions especially. For this type of question, what you do, start with this beta. Start with f1x equals to f2x. fx1 equals to fx2. How are you going to solve it? x1 minus 2 upon x1 minus 2 upon x1 minus 3, x2 minus 2 upon x2 minus 3. What are you going to do next? Better cross multiply over here. You will end up with, everything will be cancelled. You will get x1 equals to x2. I'm just giving a hint over here, okay. We have solved these questions already in my classes, but I'm just giving you a hint over here. Cross multiply x1 x2 over here, you're going to get, here also you'll get x1 x2, that will be cancelled. You'll get here minus 2 into minus 3 will be 6. You'll get here minus 3 into minus 2, again 6 will be cancelled. So just solve it, okay. If you want, you can just solve it. And don't worry, 5 p.m. I'm coming live. Any doubt if you feel by looking at these questions, come at 5, not 5 p.m., 5 a.m. live and ask me all the doubts, okay. If not, the entire solution I'll give you at least hint for every single steps that you're asking, okay. Works. And for onto function, what you're going to do, start from here. Y equal to x minus 2 upon x minus 3 is there, okay. And simply, this is not all the steps, okay. This is not all step beta. You have to do from your side, okay. You have to do from your side, okay bacha. From here, simply make subject. So you get xy minus 3y equal to x minus 2, okay. Bring x over here, 3y over there. You get xy minus x equals to, what is it? 3y minus 2. Take x common, you get y minus 1. You get 3y minus 2. From here, you're getting what? X equals to 3y minus 2 upon y minus 1. What is the constraint over here? You can see y cannot be equal to 1. Right now, because if you take y equal to 1, this becomes undefined, right? So y cannot be equal to 1. It means your range is coming as, please check, the range value is coming as y belongs to all real number except for 1. Check here carefully. That is same as the codomain. B is the codomain. It's same. Your range is equal to codomain. Therefore, fx is on 2. Fx is on 2. And how do you find inverse? If they're asking in this function only, we got this, no? Replace y by x, you get y equal to 3y minus 3x minus 2 upon x minus 1. Okay, if they're asking you to find the inverse, let's say, if they're asking you to find the inverse, let's say, f inverse of x, okay, 1 second guys, if they're asking us f inverse of x, what are you going to do? It'll become b2a first of all, and you'll have y equal to, what is it, 3x minus 2 upon x minus 1. Got it guys? It'll be a minus b, will become b minus a, b to a, not b minus a to b becomes b to a. Okay, one of the important questions, this one same result, same two or different variations which is there. These are both p by q's and very simple ones. I have solved them, please go through them. I hope you have solved it, just giving you a reminder. 5 marker question from your second derivative, bacha. This will come again, another variety is over here. This is using parametric form. Okay, differentiate first. In this you're going to find derivative like this, dy by dx equals to dy by dt upon dx by dt, right? Dx by dt. How do you find dy by dt, sir? You can differentiate this part and this part separately. From here please find this value also, because when you are finding d square y upon dx square, you'll have something over here times, what is this going to be? You'll have dx by dt also. Excuse me. Yeah, you'll have dx by dt also. No, you'll have dt by dx, na? You'll have dt by dx also. Because you'll get this function will come as a result of function in terms of a variable t. I think this comes as tan t. I remember this whole thing comes as tan t. If you solve it, if you differentiate tan, you'll get what? Secant square, which is a function of t. So you need dt by dx. Whatever you found dx by dt over here, you have to take the reciprocal. Remember that. This is a simple question. Differentiate 2 times, please. Okay. How do you find the bit of y equals to 3? Cos becomes sine, so 3 sine log x upon log, and 4 cos log x. Sine becomes cos, and log derivative is x. Take x common and put it on this side. xy1 minus 3 sine log x plus 4 cos log x, right? And now differentiate one more time. Okay, you have to use the product rule over here. Use the product rule over here. Okay, differentiate both sides, the entire equation, you can get this result quickly. Okay, done, sir. Now this is a 4 marker question. Again, it's not like prohibited, but it is not in the syllabus, it is not in your NCERT. So I would suggest you do not use L'Hopital rule. Okay, try to use standard limits. Use standard limits. I know you all know how to solve this question, right? Simply apply this condition. You can use the, let's say you're using beta LHL, okay? Then you can use this as limit of k cos x for, let's write it again. Over here we'll write, 1 second, sir. You can go like this. Yeah, limit of k cos x when x tends to pi by 2 from negative side. I'm finding LHL, right? Because for the function to be continuous, limit exists, and limit exists when LHL RHL are both equal to. Okay, so it means that the limit is existing. I'm just finding the LHL value directly. So we can write k cos x upon pi minus 2x, and this value can be written as limit h tends to 0. For LHL I can write this x as pi by 2 minus h. Okay, so it becomes cos of pi by 2 minus h. Over here same thing, replace that 2 into pi by 2 minus h. Okay, if you check this value becomes, let me write the constant outside. K is a constant, let's write outside. We'll have limit, check here, cos will become what? Sine, because 90 minus theta is there. So sine h. Over here pi minus 2 into, if this is cancelled, you'll have over here 2. You'll get this and this cancelled, means only minus pi will again will be cancelled. Okay, we'll have only minus 2h plus 2h left. Okay, plus 2h left. So if you check, when h tends to 0, this value becomes k by 2, because sin h by h for limit h tends to 0 will be what? 1. Sin h by h will be 1, and 2 will come below k. That's k by 2. This is given as 3. So you'll get k by 2 equal to 3 and k equal to 6. I have solved these questions on multiple occasions, so I know that, but just giving you some more hints. Okay, Great. More questions are there in 5 markers. These are beta 5 markers. 2 varieties. In this case, you're going to solve with x equals to a sine theta and differentiate this as dx equals to a cos theta d theta. Replace these two in this integration. What was the integration given? Dx upon a square minus x square. Replace these two, you'll get the answer. Okay, you'll get the answer as sine inverse of x by a plus c. Does it make sense? Yes, guys. Over here, take beta x value as a tan theta. A tan theta. If you differentiate, you'll get dx as a secant square theta d theta. Okay, and if you use the integration, that was dx upon x square plus a square, this will become 1 by a tan inverse of x by a. Of course, plus c will be there, and solve the other part also. 1 by, for there you're going to get x by root 7. For here you'll have, okay, for this question, no, 1 by 2x square is there. Please check, 1 by 2x square plus 50 is there. For this part, you'll take 1 by 2 common. Now you'll have dx upon x square plus 25. If you take 2 common, it will become x square plus 25. Then this question can be easily solved. This becomes what? 1 by a means 1 by 5 tan inverse of x by 5 plus c. This is what? 1 by 10 tan inverse of x by 5 plus c. Does it make sense, guys? Yes? Alright, any problem? This is another question for 6 marker. Okay, I know many of you are skipping it. You know, if you know how to solve it, you know how to solve it. Okay, you're gonna break this into 2 forms. Remember, I will give you the hint for this. Minus a to a fx dx equals to minus a to 0 fx dx plus 0 to a fx dx. Take this as beta integration I, and this as integration I1, this as integration I2. This whole question revolves around I1 only. Just take I1 and make the steps as taking s in I1, no, substitute x as minus t, substitution, and then switch the limits 0 to a. Okay, that's, and switch the variable, you get the result. This will be 0. Okay, now another question, very simple question for matrix method. We all know how to solve it, right? Correct or not? I know this is very, very important, and you all know to solve this problem. So I'm going to just give you a hint for this one also. 1, 1, 1 we have. There's no x, so 0, 1, 3 we have. And we have 1, minus 2 and 1. Am I right? Let me just check. 1, 1, 1, 0, 1 and 3. We have 1, minus 2 and 1. This is the coefficient matrix. The constant matrix is x, y, z. The variable matrix is x, y, z. The constant matrix is 6, 11, 6, 11 and 0. 6, 11 and 0. Now in this is the matrix A beta, this is x and this is b. And to find x, right, so I'll go like this, A inverse b. A inverse b. How do you find A inverse, sir? A inverse is given by adjoint of A upon determinant of A. How do you find adjoint of A? For this only we have developed this method, right? And what is that? 1, 1, 1, 1, 1, is it? Yeah. 0, 1, 3 and 1, minus 2 and 1. Repeat the first 2 rows. Please check. 1, 1, 1, 0, 1, 3 and the first 2 columns also, please. We get 1, 0, 1, 1, 0. We get 1, 1, minus 2, 1, 1. Okay. Now in this, what we got is basically, what we got is a 5 cross 5 matrix. 1, 2, 3, 4, 1, 2, 3, 4. 5 elements are there. Remove first row and first column. Now you're left with just 4 row and 4 column. So right here below, adjoint of A, draw matrix. Start from here in vertical form, this into this, this into this, and this into this. Check here. 1 into 1 minus 6 becomes 7, right? Minus 2 minus 1, that is minus 3. 1 plus 6 is 7, minus 2 minus 1 is minus 3, 3 minus 1 is 2. This is my first element. So you will take the multiplication of cross product in your vertical form and write the answer in horizontal rows. Start from here also. 3 minus 0 is 3, 1 minus 1 is 0, 0 minus 3 is minus 3, and over here we have 0 minus 1, which is minus 1. For this one we have 1 plus 2, which is 3, and we have 1 minus 0, which is 1. This is my adjoint determinant, you can find out over here. Find determinant also. We all know how to find determinant, right? Find the value and get the answer. Okay. So this is just a hint to how to find adjoint, how to approach the question. Once you have this value, put this value over here, multiply with the matrix B, the constant matrix, you'll get the answer. Okay. Comment how much you got the answer for this question. Alright, so these are some commonly occurring questions in your 5 markers. Another question, this is a linear differential equation. This is LDE, this is beta LDE. So we get here dy by dx plus 2x upon 1 plus x square y equals to 1 upon 1 plus x square the whole square. This value represents your qx and this value is your px. That's the value for your px. So integrating factor is given by integration of e power 2x upon 1 plus x square dx, because we use px for the integration. Check here, 1 plus x square derivative is present in the numerator. 1 per x square derivative is present in the numerator. It means that e power dt by t will hold true. If you take t value as 1 plus x square, I get dt as 2x dx. 2x dx. This becomes e power ln t, which means simply t, which means 1 plus x square is the integrating factor. Final answer, y into integrating factor equals to integration of qx into integrating factor dx. Check here, y into 1 plus x square, integration of 1 plus x square into, what was it, 1 plus 1 upon this x square, we have dx, this and this one cancels extra value, we are getting y into 1 plus x square equals to integration of 1 plus x square dx. Right or not? This is clear. Okay guys, this is clear. So in that case, y into 1 plus x square, and this becomes what? Integration of this value, tan inverse of x plus c. If you want to write this answer, y equal to tan inverse of x upon 1 plus x square plus c upon 1 plus x square, or you can write combined also. Yeah. But they have given the value for this, right? They have given the value for this. What value they have given? They have given when y is 0, x is 1. Y is 0, x is also 1. Okay. So y 0 means this whole thing is 0. Tan inverse of 1 will be pi by 4 plus c. Am I right? X is 1, y is 0. So this will be what? Y 0 means whole thing is 0. So I get the value of c from here as minus pi by 4. So my final answer is nothing but y 1 plus x square equals to tan inverse of x minus pi by 4. Okay, that's it. You can put this value on this side also if you want to. This is the answer, guys. 5 marker LDE. Please check. Okay, so this is the hint I wanted to give. This question also is there. Okay, how to solve this question I have taught you many times, so please go ahead and refer it. This is my part A1, sir. Okay, we know that area of the ellipse is given by 4 times of the part A1, and A1 is given by what, beta? Y dx from where to where? This is 0, this is A, major axis, 0 to A. How do you find y, sir? Y square by b square equals to a square, a square minus x square upon a square. So y becomes equals to b by a, integration of this. Put it over here, integrate the partial, particular function, get the result. Okay, yes or no? Please check. Same way, another variety of this one, this question is there. For this variety, this point is going to be minus 2 by 3. This is point 1, this is point minus 1. Okay, your feasible region here is what? This one and this one. If you want to integrate, you're gonna go like this, 3x plus 2 from where to where? Minus 1 to minus 2 by 3. But this value is below x-axis, so we need positive side, so we're gonna use modulus over here, and plus other part, 3x plus 2 from where to where? Minus 2 by 3 to 1. This is easy one. Solve it. This answer comes as 13 by 3, basically 26 by 6. But this part actually comes as 1 by 6, and this part comes as 25 by 6, I think. Yeah, please check. Okay, so I have solved all these questions for you, just giving you a revision. Cos x integration from 0 to 2 pi. Again, I have solved this problem. Just do one thing, create 4 parts. Part 1 is positive, part 2 is negative, again negative, and again positive. Simply integrate this part, integrate cos x dx from 0 to pi by 2, because this value is pi by 2, and multiply with 4. That's the answer, and this value will actually come as 4 square units. Got it, sir? Okay, so like this, the more questions I've taken, you can just go through this. Please check here. I'm going to show you once. This is your question. The answer is given over here. Solution is already given. You know how to plot it. Just revise these problems. Come in my classes, in the live classes 5 a.m. and ask me your doubts. Okay. So this is the list of 5 and 6 marker, 4 markers. But I have given your list of 2-3 marker questions. Okay, if you go and check, I've given you list of 2-3 markers also, and we'll make sure that you get the PDFs. Check here. More and more questions are given to all of you. Okay, here beta, write the following functions in the simplest form. In trigonometry, there are a lot of variations are there. I've taken all the variations. You know how to solve it, right? For this question, take x value as a sine theta. For this question, simplify. Sine inverse of 1 by 2 will be pi by 6, and so on. Okay. For this question, simply this formula will be true beta. Tan inverse of 1 minus tan inverse of x equals to 1 by 2. Tan inverse of x. Move on this side. Get the answer will come as, I think, 1 by root 3. For this problem, divide by cos x in numerator and denominator. Both. Right? And then you can get the answer. For this one, again, just move this part over here and then apply sine. You get 1 minus x equals to sine of pi by 2 plus 2 sine inverse of x. Then you can solve it. Okay, this will become 1 minus x sine of it will become cos, right? It will become cos of 2 sine inverse of x. There's a formula, 1 minus 2 sine square of sine inverse of x. This value becomes 1 minus x square. Sorry, 1 minus 2x square. 2 is outside now, because sine of sine inverse is going to be x. We have a square over here, that's why x square we get. Okay, so this question, use 1 minus cos x as 2 sine square x by 2 and 1 plus cos x as 2 cos square x by 2. What I'm doing over here is giving you hint how to go about this question, because usually we know how to solve it, but we get stuck knowing how to start the problem, right? For this problem, take this as angle alpha and beta, and from here your sine alpha beta is given as 5 by 13, and cos beta is given as 3 by 5. From here you find tan alpha, from here you find tan beta. Find these values please, and use the formula of tan of alpha plus beta. Whatever result you get, apply tan inverse, you get the answer. Okay, find this value, whatever result you'll get, apply tan inverse, then you'll get the answer. Okay guys, again few more questions. These two are logarithmic differentiation, comes for 3 marks. Please check. 3 marker from your relation and function. Okay, this is again logarithmic differentiation. So as you can see, all these questions are listed over here. You're gonna take in this question 2 par x as tan theta. Okay, and then simplify it, you'll get the answer by I think answer should come as 2 into 1 upon x square. Please check. No, ln x will also come, right, because you differentiate this also. But yeah, solve it. Simple question. Okay. Yes, few more questions. This is a pakka question from partial fractions in 3 marker. Pakka question will there. I've solved this question many occasions. Okay, so this is going to be picture. And how would you solve this problem? This is your eyelet problem by parts. For this question, sine of x plus a minus a, please use this. Use the formula of sine of a minus b. If you take this whole thing as capital A and this whole thing as capital B, you have the formula of sine of a minus b. I hope you remember. Sine a cos b minus cos a sine b. Use that formula, simplify and get the result please. This sine of a minus b, right? Correct? Okay, so this is a 3 marker in your matrix method question. So likewise, I have given you questions list for everything. Download this PDF, go through it once. Okay, so I've tried my best to give you all what you need to do, and this is going to be better end of your class today. I don't want to spend more time over here because as you can see there are many. Okay, I've given you all the question lists that I can. If you want to revise through them and ask me, the best part is I'm coming live at 5 p.m. If you want to ask 5 a.m. I keep making this mistake. 5 a.m. I am coming live. Okay, you can come and ask me all your doubts. I'll make sure that this PDF is given to you guys at the same time when I'm doing this particular class itself. So it'll be attached over there. Okay, you can download the PDF and get working on it and ask me your doubts. Got it? That is it for this particular session. I'll see you in the live. All the best. I hope you don't need anything else, but if you do need, you can come and ask me. Okay, I'm here to support you in every way possible, and again after your paper I will be coming with the paper discussion all the time. Okay, so that's all guys, all the best. I love you a lot. Just keep working hard, keep smiling, and keep yourself positive, and go take some rest as well. Okay, take some rest, have yourself some, give yourself some time, breather, freshness you need, and go ace this examination of boards. Okay, all the best, take care, bye bye.